Welcome to improper integrals with 1 over x to the p. So recall when we found that the integral of 1 over x squared dx from 1 to infinity was equal to 1. And so we had that the integral from 1 to infinity of 1 over x squared dx is finite. Right? In general, we have that the integral from a to infinity of 1 over x to the p dx. My screen. The integral, definite integral from a to infinity of 1 over x to the p dx. It turns out that this for a greater than 0, it turns out that this is finite for p greater than 1. So x squared, our p was 2. We can see that since integral from a to infinity of 1 over x to the p dx would be equal to the limit as b goes to infinity of the integral from a to b of 1 over x to the p dx is equal to the limit as b goes to infinity of negative 1 over p minus 1 times 1 over x to the p minus 1 evaluated at a and b. This will be the limit as b goes to infinity of negative 1 over p minus 1 times 1 over b to the p minus 1 minus 1 over a to the p minus 1. And as b goes to infinity, that 1 over b to the p minus 1 will go to 0. And so we wind up just with 1 over p minus 1 times 1 over a to the p minus 1. Right? So this is finite when p is greater than 1. For p less than 1, it's actually infinite. For p less than 1. So in this case, our integral from a to infinity of 1 over x to the p dx, again, is our limit as b goes to infinity, the integral from a to b of 1 over x to the p dx. This is equal to negative 1 over p minus 1 times x to the 1 minus p evaluated from a to b. The reason I wrote that as 1 minus p, if p is less than 1, oh, sorry, I forgot my limit here. So we still have this is equal to the limit as b goes to infinity. The reason, since 1 minus p will be positive and greater than 1, right? We wind up with, or it will be positive, sorry. We wind up with, this is equal to the limit as b goes to infinity of -1 over p minus 1 times in parentheses b to the 1 minus p minus a to the 1 minus p. Again, 1 minus p is greater than 0. We have that this is equal to infinity, or in fact, yeah, this is equal to infinity since 1 minus p is greater than 0. So we have infinity raised to a positive power, essentially. And furthermore, it is also infinite for p equals 1. So in this case, we are looking at the definite integral from a to infinity of 1 over x dx. This is again the limit as b goes to infinity of the definite integral from a to b of 1 over x dx, which is the limit as b goes to infinity of natural log of the absolute value of x evaluated at a and b. So we wind up with a limit as b goes to infinity of the natural log of b minus the natural log of a. Natural log goes to infinity as its inside goes to infinity, so we get infinity. Right, so in summary, we get that the definite integral from a to infinity of 1 over x to the p dx is equal to, or converges, if p is greater than 1 and diverges, or is infinite, if p is less than or equal to 1. Again, for our convergence case, essentially, I mean that this is finite. We can do a similar thing for the integral from 0 to 1, or 0 to b. Right? So we can pull a similar trick. For the integral from 0 to b of 1 over x to the p dx. So for that, recall that we saw the integral from 0 to 1 of 1 over the square root of x dx was equal to 2. And so, in other words, it's finite. We also saw in evaluating the definite integral from -1 to 1 of 1 over x squared dx, we saw that the integral from 0 to 1 of 1 over x squared dx was infinite. So it turns out that in general, the definite integral from 0 to b of 1 over x to the p dx converges for p less than 1, so again, is finite for p less than 1, and it diverges for p greater than or equal to 1. Again, is infinite. So we immediately know if you have a case where we're looking at, say, the integral from 0 to 1 of 1 over x cubed, we immediately know that that will be divergent. That's an infinite integral. And so you can use this trick as a means of checking sometimes if various improper integrals will converge or diverge. So in the next video, we will learn some tricks for verifying if an improper integral will converge or diverge for functions other than 1 over x to the p.